If I take a look at this next guy, again, we're just transforming, and really, our parent graph is this guy. It's the one that we've been dealing with, the one that we know, that we're very familiar with, and keep that in mind. That's the guy that looks like this. Okay, we go over 1, up 1, and then over 2, up 4, over 3, up 9. Okay, that's the parent graph that we're talking about. So if I look at this one, when I add to the x, that moves us to the left that many units. When I subtract from the outside, it moves me down that many units. So that means I'm going to go to the left 1, down 2. So that means I'm going to start here. So that's where my vertex is. And if this is helpful, imagine that this is now your your y-axis, and this is your x-axis. And if we picture it that way, the original graph, the parent graph, would look like this. Okay, that's what the parent graph would look like. So if I was looking at this parent graph, really the a value stretches this thing vertically. So instead of being the same height as my parent graph, everything's going to be stretched vertically by a factor of 2. So think of it this way. Right here, instead of having this go up 1, it's going to go up 2 instead. It's going to be twice as tall. Right here, instead of going up 4, it's going to go up 8 instead. It's going to be twice as tall. Okay, here, instead of going up 1, it's going to go up 2. Here, instead of going up 4, it's going to go up 8. So I'm stretching this thing vertically. So let me get rid of all the fluff that's here. I'm stretching it vertically, so it makes this thing much, much larger. It stretches it in the direction of the y. So each of those heights that we discussed just becomes twice as much. Instead of going up 1, it goes up 2. Instead of going up 4, it goes up 8. And the result is I get a graph that looks much skinnier. Okay, if I stretch something vertically, of course it's going to appear skinnier. All right. If I take a look at this guy, again, subtracting here moves us to the right. Adding on the outside moves us, wow, why don't I just cross out the 4? How about that? Yeah, adding on the outside moves us up. All right, so I'm going to go to the right 2 and up 4, which puts me here. Again, my parent graph, if I imagined that this was my y and this was my x, my parent graph would do this. Up 1 over 1, 1 over 1, over 2, up 4. Okay, so my parent graph would look like that, but I'm going to change this by a factor of -1/2. The negative means it's going to open in the opposite direction, and the 1/2 means everything's going to be half the height that it was. Okay, I'm changing the y value by a factor of 1/2. So instead of going up 1 right here, I'm going to go down 1/2. Instead of going up 1 right here, I'm going to go down 1/2. The next one, instead of going up 4, I'm going to go down 2. I'm going to go down half that much. Instead of going up 4, I'm going to go down 2. I'm going to go half that much. The next one, I would go over 3, down 9. Instead, I'm going to go down 4.5. Down 4.5. And that's it. Okay, so again, the effect that this has, that's terrible looking. Let me try that side again. Oh, or the whole thing again, why not? The effect that this has is I get a parabola that looks wider, all right? Because I'm shrinking it vertically, because I'm squishing it down, it's going to appear wider. And that's it. If I take a look at the next guy, I want to shrink this vertically, shift it to the left 2, and down 1. To shift it to the left, I add 2 to the x value. To shift it down 1, I subtract 1 on the outside. And to shrink it vertically, I change the a value by a factor of a fraction, something between, this has to be between then 0, I should write it this way. I want an a value that's between 0 and 1. Okay? So in other words, I'm just going to tweak it. I'm going to put a 1/2 in here, and you could use something else like a 1/3 or 1/4. If I shifted it to the left 2, I added 2 in here. Well, there was already a +2, and if I add 2 more, it's now going to be a +4 squared. On the outside, I had a -4, but now I shifted it down 1, so I subtracted 1, so that's going to give me a -5 instead. And that's it. Okay, and again, this could be different. You could have a different fraction there. As long as it's something between 0 and 1, you're good to go. For the next one, it says to write the equation of the parabola whose vertex is 2, 1 and passes through the point 3, 5. So remember, the two things that I need in order to write the equation of a parabola are the vertex and the a value. The vertex is given, it's 2, 1. So now I just need the a value, so I'm going to use a fresh y equals a times x minus h squared plus k. And I'm going to plug in what I know. A is the thing I'm looking for, but right here I've got an x and a y value. Remember, my vertex is hk, so the x is 3, h is 2, k is 1, and the y is 5. And now I just have to solve for a. So I'm going to simplify. 5 equals a times, this is going to be 1 squared plus 1. So let's see, 1 squared is 1, so that's 1a plus 1. I subtract the 1 from each side, so that's 4 equals 1a, which is just a. So a equals 4. I've solved for a, and now I just have to write my equation. My equation is y equals 4 times x minus h, which is the 2, squared plus k, which is the 1. And that's it. All right, I find the vertex, find the AVL, plug it in, and I'm done. All right, last one. Last one. I thought we'd never get here, Mr. Jansen. It says if a ball is thrown into the air from a platform that is 64 feet tall with an initial velocity of 48 feet per second, 48 feet per second, modeling the equation, so I've given you the equation. That was awfully nice of me. And I want to know what will its maximum height be. And the thing that makes this super easy is that maximum is just a fancy word for vertex. So really what this question is saying is find the vertex. So if I've got this equation and I want to find the vertex, I find it the same way I've always found it. I do the opposite of b over 2a. So that's a negative 48 over 2 times a negative 16. So that's a negative 48 over a negative 32, which reduces, a negative divided by negative is a positive, and this is going to be 3 halves. They're each divisible by 16. So I've got a 3 halves here. And I have to find the y value for the vertex. And notice, this is the x value, or in our case, it's a t value because we've got t's in here. Keep that in mind. Okay, so that's our t value. And now we just have to plug that in. Negative 16 times 3 halves squared plus 48 times 3 halves plus 64. And I just have to simplify this. That's negative 16. 3 halves squared is 9 fourths. Again, 3 squared is 9. 2 squared is 4. Over here, you can imagine that this is like over a 1. You can cross-reduce the 48 and the 2, reduce to a 24 and a 1. And a 24 times 3 is a 72. Over here, again, I'm going to pull the same trick. I'm going to cross-reduce the negative 16 and the positive 4, reduced to a negative 4 and a positive 1. And I'll multiply straight across. That's going to be a negative 36. Negative 36 plus 72 is a positive 36. And positive 36 plus 64 is 100. So I found the vertex. But keep in mind, I'm not quite done yet. It asks, what will its maximum height be? And if I'm talking about height, am I talking about the x or the y? Well, x talks about the horizontal shift, okay, left and right. The height has to be the y, so we're talking about the y value here. So that's going to be 100, but more specifically, it's going to be 100 what? Well, it's going to be 100 feet, because this was in feet per second. In other words, this is seconds, and this is feet. So that's it, 100 feet. I hope this was helpful, and good luck on your test tomorrow.